Hello friends, today's concept is about relationship between numbers, which is SSC Quantitative Aptitude Concept 4. We already seen computation of whole numbers, decimals, fraction in the previous videos. This is relationship between numbers concept 4 part 1. Here I explain a definitions and examples. The second part only some examples. Okay, let's move to the video. If the last digit is 0, 2, 4, 6, 8, then it is divisible by 2. If a number given, a last digit is an even number, then it is divisible by 2. If the sum of the digit is divisible by 3, then it is divisible by 3. If we add each and every digit in a number, if that sum is divisible by 3, then it is divisible by 3. If the last two digits are divisible by 4, then it is divisible by 4. In a number, last two digit is divisible by 4, then it is divisible by 4. If the last digit is 0 or 5, then it is divisible by 5. If in a number, last digit is 0 or 5, then it is divisible by 5. If it passes the rules for both 2 and 3, then it is divisible by 6. The divisibility rule of 2 and 3 is satisfied, then it is divisible by 6. We need to solve this 2 divisibility rule for finding divisibility of 6. Next, I leave one actually for divisibility rule of 8. It's related to 4, so it comes like if the last 3 digits are divisible by 8, then it is divisible by 8. Actually, I missed that note. If the sum of the digit is divisible by 9, then it is divisible by 9. It's related to 3. Like a 3, if we add the each and every digit in a number, if the sum is divisible by 9, then it is divisible by 9. Next, if the last digit is 0, then it is divisible by 10. In a number, last digit is 0, then it is divisible by 10. If it passes the rules for both 3 and 4, then it is divisible by 12. Divisibility rule of 3 and 4 are satisfied, then it is divisible by 12. That's all divisibility rule. Next we move to example. Example 1. When a number is divisible by 45, the remainder is 21. What will be the remainder when the number is divided by 50? One number is given, it is divided by 45, we get the remainder 21. If the same number is divided by 15, what is the remainder? They asked that. First, 45 is divided by 15. So, this number is also divided by 50. So, we leave that number. Now, we go to remainder. We need to solve this remainder 21. When 21 is divided by 15, we get 115, 6. So, remainder is 6, which is answer. Next question, a 9-digit number 846523x7y is divisible by 9 and y minus x equal to 6. Find the value of root 2x plus 4y. A 9-digit number is given, their 2 digits are missing. They are written as xy. This 9-digit number is divisible by 9. And one expression is given, y minus x equal to 6. We need to find root 2x plus 4y. First we need to find x and y. Then we move to root 2x plus 4y. By divisibility rule of 9, we need to sum of the digits which is divisible by 9. That is divisible by 9 rule. So we need to sum this number 8 plus 4 plus 6 plus 5 plus 2 plus 3 plus x plus 7 plus, in the place of y, I need to put x plus 6 equal to, this sum is divisible by 9, then the sum must be in multiple of 9. So we take it 9k. Now we need to add this 10, 20, 28, 35, 41. So 41 plus x is 2x equal to 9k. The number which is nearer to this 41 in 9 multiple is 45. So we need to write this place 45. So 2x equal to 45 minus 41. So 2x equal to 4, x equal to 2. When we substitute this value in here, we get y equal to 2 plus 6, which is equal to 8. Now we need to find this root 2x plus 4y equal to root of 2 into 2 plus 4 into 8, which is equal to 2 2s are 4, 4 8s are 32, is equal to root 36 equal to 6. This is answer. Next question. A 4-digit number 𝑎𝑏𝑏𝑎 is divisible by 4 and a less than b. How many such numbers are there? One 4-digit number is given, not a number, it's in a letter. We need to find that number. 𝑎𝑏𝑏𝑎 which is divisible by 4. A less than b also given. In this format, how many numbers are there? They ask that question. We need to find that. 2-digit number which is divisible by 4. We write the 2-digit numbers 12, 16, 20, 24, 28, 32, 36, 40, 44, 48, 52, 56, 60, 64, 68, 72, 76, 80, 84, 88, 92, 96. 100 means it is 3-digit number. We just need to write a 2-digit numbers. Here we need to see which all satisfy this rule. A less than b. That is, first digit is greater than second digit. This not satisfied. This also not satisfied. For 0, when we take this 20, the first digit becomes 0. Then it becomes 3-digit number. We just need 4-digit number. So we did that not involve the 0 digits too. So we leave this. This also not satisfied. This also not satisfied. 32, which satisfied because first digit is greater than second digit. So this satisfied. This not satisfied. This also not satisfied. This also not satisfied. This also not satisfied. This is satisfied because 52, which first digit is greater than second digit. This not satisfied. This also not satisfied. This satisfied. This not satisfied. This satisfied. This also satisfied. This not satisfied. This satisfied. This also not satisfied. This satisfied. This satisfies. Now we add this 1, 2, 3, 4, 5, 6, 7, 8. So the answer is 8. Like, share and subscribe friends.